Hi, I'm Sungjin Choi from KAIST. I'm going to introduce my work, B-cell epitope prediction by capturing spatial clustering property of the epitopes using graph attention network. B-cell epitope is the binding site from the antigen which interacts with antibody. As we know more about the epitopes, we can use it for vaccine design, diagnostics, and therapeutic approach. So many in silico tools were developed, but their performance was rather close to random. In our work, we used ISM-based pre-trained model embeddings to capture the evolutionary structural features of the B-cell epitopes. We also used the GAT layer with residual connection to improve the model performance. This helped in understanding the clustering features of the B-cell epitopes as well. The model architecture looks like this. Given the antigen, we used the ESM inverse folding and ESM2 features as node feature for graph neural network, and we performed node classification test which predicts the probability of each amino acid being the epitope. As the layer goes deeper, there are chances of initial features being lost. So we added residual connection to make models to remember the initial state. Dataset was collected from Epitope 3D. You can see that some levels of class imbalance exist. When the data imbalance is there, AUC-ROC gives optimistic result on the classification task. Therefore, we additionally use MCC, PACC, and AUC-PR. AUC-PR is the threshold-independent matrix which is helpful to evaluate the general prediction performance. We trained and evaluated on the surface residue because predicting the binding interface of the core is rather meaningless and it can give overestimated result. When we compared our model on the benchmark set, we could see that our model is the state-of-the-art model in comparison to other methods, including the recent ones which is better predicted than others, namely BFP-PRED3 and Discotope 3. I did not add the AUC-PR in this table, but even AUC-PR was lower than our models. To see the robustness of our result, we also tested on the Discotope 3 benchmark test set. The result was consistent, which shows our model superiority. In evaluation study, we perform both feature evaluation and architecture evaluation to see which part was beneficial. We could see that the ESM features individually helped, and when they are combined, it performed better. And when we used the MLP layer, we could see that the GAT model performs better, and also when we added the residual connection, it gives better performance. Finally, we visualized the prediction result to see how homophily in the graph neural network resembles the B-cell epitope clustering patterns. These are the predictions from good, medium, and bad cases. We can see that model is trying to get the high signals being close to each other. So in summary, we showed the model superiority in terms of feature engineering and model architecture. Using pre-trained model embeddings helped in B-cell epitope learning. Also, GNN could capture the B-cell epitopes being clustered to each other using graph homophily. Finally, the accurate epitope prediction could contribute to the vaccine design and antibody engineering. Thank you for your attention, and if you have any questions, feel free to ask. I added my email address on the bottom right. Thank you.